ボーナスだ。
Okay, I just wanted to show a demonstration of the breadboard circuit for the bonus cigar tube circuit tester. As you can see here on the board, on the positive rail of the breadboard, I have an orange jumper wire, and this orange jumper wire represents the paperclip probe on the cigar tube circuit tester. This is the bonus design here. There's also a second jumper wire here, this red one, and this red one is acting as this secondary probe that's attached. It's actually attached to the paperclip probe here within the circuit that's inside the tube here. So in reality, this point and this point are the same points. This just gives the ability to whether or not you want to use a pointed test probe end or an alligator clip probe end. So that's what these two jumper wires represent. I have this orange jumper wire here from the positive line going to this diode here. This is the anode end of the diode, and this end is the cathode end of the diode. And this diode represents diode D1 as seen in the circuit tube or cigar tube circuit tester bonus schematic. From there, we go through resistor R1. It's a 1.2 kilo ohm resistor, and from there it goes directly to the anode of the green LED, and then the cathode of the green LED is on the negative rail here on the breadboard. You can see that I have this buzzer here, and I have its red wire going to the positive rail, and I have its black wire going to the negative rail. It's in parallel with all these components here. So the buzzer is getting the full voltage potential across this entire circuit here. So in this case, I'm going to be testing with a 9-volt battery, and then when I connect the probes to this 9-volt battery, in the positive, or in the ground, in the negative ground orientation, that will provide the full 9 volts across this buzzer, and it will make the buzzer sound off. And then of course we have our black negative probe here, which represents the black wired alligator clip here, which comes from the very end of the cap of the cigar tube tester. So in order to demonstrate, I'm going to connect the probes. I'm going to start with the orange probe. So this orange probe represents the paperclip probe, and I'll take the black jumper wire here, and I'm going to touch it to the negative terminal of the battery. And this black jumper wire, if you can see it, this black jumper wire represents the black alligator clip. And you can hear that when I have this circuit in a negative grounding orientation, meaning that this black jumper wire, which represents the black alligator clip, when it's touching the negative terminal of the battery, or if you have it touching a negative point in a circuit, and then when you touch the positive probe, which is represented in the orange one here, which is represented as the paperclip probe, when it's touching a positive point in the circuit, or in this case the positive terminal of the 9-volt battery, then the green LED lights up and the buzzer sounds off, and both tell us that there is a voltage potential coming across these two probes. Like that. Now, if I use this red jumper wire, which represents the red alligator clip, and again I put the probe onto the positive terminal of the 9-volt battery, and again taking the black jumper wire, which again represents the black alligator clip, and I touch it on the negative terminal of the battery. Then the green LED lights up and the buzzer sounds off. If I were to switch these around, and now I have the red jumper wire, again, that represents the red alligator clip, and I take the black jumper wire and touch the positive terminal instead of the negative terminal this time, then nothing happens. Neither the LED or the buzzer sounds off, because this represents positive ground orientation, meaning that our positive jumper wire here, which again represents the red alligator clip, is touching the negative terminal of the battery, and our black jumper wire, which represents the black alligator clip, is touching the positive terminal. So if we're thinking of this black jumper wire as being our negative wire, if I'm touching the positive terminal of the battery, that means I have it at positive ground. And since I have it at positive ground for this bonus design circuit, it will not make the green LED or the buzzer go off. It has to be in negative grounding orientation, with the positive jumper wire being at the positive terminal of the battery and the negative jumper wire being at the negative terminal of the battery.